Good afternoon. مساء الخير. Today I'll be speaking about climate change in Egypt. The presentation we will start with a background about climate change, the most recent development, background about a project that we are undertaking at the University of Alexandria in terms of vision, objectives, and methodology of work, as well as the main components and activities of the project. And we will conclude with considering the Egypt's vulnerability to climate change. The most recent development on climate change is the IPCC AR5, Assessment Report 5. The IPCC has 3 groups. Working Group 1, considering the science. Working Group 2, considering assessment of impacts and vulnerabilities adaptation. And Working Group 3, working on mitigation. The first group submitted the report in October last year. And that's what they came up with. It's about the temperature change globally. Under different scenarios, we're talking about between 2 and 4 degrees. We have here the scenarios, different scenarios, the change in temperature in the coming 50 years and up to 2100, and the associated change in global mean sea level rise. That's what we're talking about. We're talking about right now between 28 centimeters and almost 1 meter. There are research saying that it would be more than that, but that's the most credible assessments that they came up with. In terms of the Working Group 2, the report was out last week in Yokohama, Japan, and it's unequivocal. It's expected to happen, and it's happening. There are a lot of observed changes in climate that we haven't seen before. The observations suggest that the atmosphere and the oceans have warmed, and the amount of snow is diminishing. Sea level is on the rise, and that's associated mainly with the concentration of greenhouse gases. A lot of ecosystems are already affected by the changes, and it's expected that the change will be much more severe over the coming years. Crops will be affected. Productivity for most crops will decline, and that will have serious consequences on food security at global and regional level. There has been changes due to extreme weather events since the last report, AR4, in 2007, suggesting that the markets are very sensitive to extreme weather events, and that affects the supply as well as the prices of different crops at global levels. Vulnerability, when we talk about vulnerability, we're talking about the extent of impact and the extent of effects on different people due to climate change, it's not just about climate change. Actually, climate change is one of the factors influencing what's happening. We're talking about socioeconomic conditions, poverty, unemployment. All this will be accompanied by climate change, which will mean that the effects will be much higher, especially with the higher exposure for developing countries. The higher exposure for developing countries, not because they are developing countries, it's because about their geographical locations, and this is also affected by the socioeconomic conditions in these countries. As I said, that extreme weather events is expected to have serious impacts on food, ecosystems, production, water supply, different aspects. And the hazards will affect the poor more than anybody else. Now about our project. It's a project supported, a research project supported by the IDRC Canada. If you look at any reports concerning climate change about sea level rise, you'll find out that the Nile Delta is one of the most vulnerable areas to climate change. That's an image from NASA, Egypt at night. The Nile Delta and the Nile. That's the life of Egypt in that area. Most agricultural production, largest urban centers in Egypt, economic activities, fish catch from aquaculture and marine environments. The population we're talking about, on average, more than 1,600 people per square kilometer. I believe that if you have read anything about climate change, sea level rise, and the impact on the Nile Delta, you'll find out this map. And I believe that we've been sort of arguing for the last couple of years. Some people are saying that 20% of the Nile Delta will be inundated by sea level rise. People will say 30%. Some other people talk about 50%. But the problem is nobody asked what are the underlying hypotheses, what are the underlying assumptions of the research they have done. What we have here is a map showing the areas that will be at risk of inundation under 3 hypothetical scenarios: 1 meter, 2 meter, 3 meters. Most of the research that has been done so far focused on the physical impacts, the areas that will be inundated, and the typical question that you would hear from people is, are we going to be resettled somewhere else? When will happen? What will happen then? Current condition. If you're talking about areas that will be inundated in 2050 and 2100, you cannot just come and say that these areas are inhabited by like 2 million people today, and this means that 2 million people will be affected. Actually, we're talking about 2050, 2100, which means that we need to have projections about the economic, socioeconomic, and demographic conditions. We need to understand what are the options for adaptation. What can we do to minimize the adverse impacts of sea level rise? What about the wetlands? Everybody's talking about the coastal areas will be inundated, including the wetlands. But actually, wetlands will be inundated, but they still will be wetlands. What will happen is the ecosystems of the wetlands will change. In what direction? We are not sure. What about the adaptation cost? In order to adapt to such impacts, how much will it cost? Is it worthwhile? Are we going to protect every inch in the coastal area of Egypt? Economic-wise, it doesn't make sense. If it's undeveloped, there's no point of protecting if the protection cost is higher than the value of the land we're talking about. As I said, most of the research that has been done on climate change focused on inundation, focused on the physical impacts. What are we trying to do is to reorient the work to start focusing on adaptation. We need to work on impacts. We need to work on vulnerability. But we cannot stop at that. The next step is what can be done, what should be done. So that's the first item. The second item is promoting knowledge sharing. By coincidence or by chance, if you look for some papers on climate change, on sea level rise, impacts on Egypt, you'll come by some of the papers. So what we've tried to do is to collect all the materials, research work, reports, and so on, so that we will have inventory of everything that has been done in order not to start every time from scratch. Most of the time, researchers complain that policymakers do not listen, that policymakers should wait until we do our research, make sure that we get the most out of the research in terms of results, quality of the work, and so on, and then they should take it over and use it for policymakers. Actually, for policymakers, it's a different story. They have a cycle as well for policymaking. If they don't have the information at the right time of the quality that they would require, they will have to make decisions, they will have to develop policies without waiting for us researchers. So what we are trying to do is to reverse the equation. We start with some of the questions of concern, issues of concern for policymakers, and we try to do work and do research on, so that whenever the outcome will be available, that will be of actual interest to policymakers. And the final item is about having experience exchange. No entity, whatever the capabilities of it, can work on climate change and claim that they are covering the whole topic of climate change. Climate change will affect all sectors that you can imagine. We're talking about from agriculture, water, tourism, coastal areas, marine environment, biodiversity, built-up areas, whatever topic you think of will be affected by climate change. So we need to work as networks, not as individual entities. Each is claiming to work to cover the whole topic of climate change. And that's what I'm trying to do. So the specific objectives that we're talking about is related to the vision that we just presented. We're talking about centers, it's not about buildings, we're talking about institutional capacities to conduct work. And the second part is competent research capacity supported, an enabling environment for effective policy research interface created, and also we have to conduct rigorous research to support decision and policy making. So we're talking about capacity building for researchers as well as stakeholders. Small research grants program, research on adaptation on the impacts of climate change and sea level rise on the coastal areas of the Nile Delta, and creating a multi-stakeholder dialogue concerning different issues related to climate change. For capacity building activities, we have two types of workshops. One type is technical workshops for researchers, and the second for stakeholders, different stakeholders, covering different topics related to climate change. I would like just to stress a point that one of the problems for us in Egypt about research is the lack of research skills. So what we've tried to do is we developed a number of workshops to support researchers. One of the topics that we are covering is like how to develop a project proposal. Because Egypt, the number of projects, research projects supported by international donors in Egypt is limited. And during consultation with different donors, we've heard that the number of proposals submitted from Egypt is normally small, and large proportion of what is submitted is actually of low quality that cannot compete with other countries. That's the type of capacity building activities that we're conducting. We've started in 2011, and so far we have conducted 34 training workshops. We have the number of applicants is more or about 1,200 applicants. Participants, we had 575, covering different topics, as you can see. The affiliation of different participants, we're talking about ministries, we're talking about different universities. What we're trying to do is to keep everybody in touch, in contact. We're developing mailing list of all people, applicants and participants, so that everybody who would be interested in our activities or doing some research related to the topic that we're talking about will be easily accessible for us. Research work. We tried to deal with the issue of topics that would be based on interest of a researcher or a research project. When they are done, and they start on another topic, maybe related or not related to the previous topics. So what we're trying to do is to create an integrated approach to research that would support decision makers and will provide a better understanding about different issues associated with climate change impacts, vulnerability, and adaptation. So we developed a plan for that. Some of the research activities are conducted by the core team of the project. Some are conducted by, through small research grants. Some is conducted through supported students with scholarships to work on specific topics related to the plan that we're talking about. Some of them are already completed, some in the process of completion. Part of the project, we have a small research grants. We had 4 calls, announcement. We had 36 submissions, shortlisted concept notes were 7, and finally accepted and final projects, 4 projects. They are covering a wide range of topics, from marine biodiversity, impacts on ecosystem of the wetlands, the effects of sea level rise and saltwater intrusion on the built-up area in terms of buildings and infrastructure, and also about animal production, the impact and vulnerability of animal production to climate change, and the potential adaptation options under Egyptian conditions. We have a number of papers published within the themes that we have presented so far. The point I want to stress in here, that when we talk about climate change is not just sea level rise. That's part of the story. And we had a previous project covering the coastal area of Damietta, Governorate, and we found out that 2.4% of the coastal area is potentially exposed to sea level rise, but the main and serious problem is saltwater intrusion and the impact on groundwater in terms of salinity and the level of groundwater. That will affect buildings, foundations, and also agriculture yield and productivity.
5 minutes.
Okay. We're talking about different sectors. What's going to happen to agriculture? We're talking about heat, water requirements for crops. We're talking about pests and diseases. A study that was conducted in 2008 suggests that with the projected sea level temperature rise, water requirements will go up by up to 13%. There will be adverse impacts on crop yield. Different studies. All products, all crops will be adversely affected, except for one, which is cotton. Other than that, all crops will be adversely affected. But still, more research is needed. If you talk about livestock, same story and same conclusion. Still, more research is needed. Fisheries, what will be the impact on fisheries? Whether we're talking about marine environment or we're talking about aquacultures in the Nile Delta, still more research is needed. Despite that 80% of the fish production comes from aquaculture, the Nile Delta. Coastal areas, vulnerability, coral reefs, tourism will decline. Fish stock will be moving northward to much suited marine environment. What will this mean for fishing activities? We're talking about coastal dynamics, erosion, accretion will change with sea level rise. How this will change, what sort of impact to expect. We need to know more about it. What will be the socioeconomic impact of inundation by sea level rise? Is it just we're talking about a couple of million people who will be resettled? Resettlement of people is not as easy as just taking them from their place and putting them somewhere else. It's a totally complex story. Again, saltwater intrusion, buildings, foundations, still more work needs to be done. So we're talking about dynamic physical and socioeconomic situation. We'll need to update and work with the different scenarios. And not to consider the status quo as the issue of concern. Considerable amount of data and information should be gathered through field surveys and data collection. And we have to employ different analysis techniques for different disciplines. Networking, if we don't go for networking, it's not going to work. We're talking about different universities, research institutions. We're talking about even Ministry of Environment, Egyptian Environmental Affairs Agency. That's part of the decision-making process. Thank you.
We have time for one or two questions. Yes.
I wanted to ask whether the delta inundation is expected to be a sudden one, or would it happen gradually?
Okay. The problem with the early research on sea level rise, everybody's talking about what's going to happen in 2100. Actually, you're not going to wake up in 2100, or whoever will be there at that time, and just will find out that sea level is rising. Actually, it's a gradual thing. And one of the issues of concern is, we did some work, and you know that the delta is subsiding by itself since the Swan Dam. So even without sea level rise, some of the areas will be exposed to inundation. And we need to take care of this. We are not talking about major investments, because the story that we're talking about has uncertainties. So what are we saying is, go for the no-regret options. No-regret options is like, don't go and do development in areas expected to be exposed to sea level rise. Do it somewhere else. Don't do it there and then ask question about how can we protect it. That's not going to cost us money. Making decision about the right places that are not exposed to the impacts of sea level rise. Thank you.
The Nile will also rise. Because if you have a rise in the sea, you'll have a rise in the Nile also. You know, throughout Aswan or something like that. Is that in your study? Because that will have some repercussions unless the Nile waters rise up.
Well, the Ministry of Irrigation has conducted a number of studies, and a number of scenarios were developed for that. And we're talking about a range of projection for the water flow of the Nile between a minus 80% and plus 20%. The issue for the Nile, if the flow of the Nile will decline, the problem is you will have more seawater intrusion into the Nile Delta area. And that will magnify the impacts that we're talking about. Thank you.
Okay, well, thank you very much, Professor.
Thank you.
Good afternoon. It's a pleasure to be here. This Biovision is always very nice. People are very nice. We love to be here. Well, I'm going to talk to you. Well, I'm going to talk to you about an opportunity to how to be good and profit at the same time, and good to the environment and profit to your pockets, I hope. Look here. This is based on the opportunities that waste electronic and equipment offers to developing countries. We all have dozens of equipment at home that we don't use anymore, and we don't know what to do with it. A lot of it is thrown out of the street. It goes through a catcher destroys it a little bit more, leaves it there, and then goes to the jump yard, and it just pollutes and everything. My name is João Paes de Carvalho. You almost got it. And I'm a director of Business Brazil, and I'm starting a company called Renova TE, which is works with ICT equipment, mainly on the business-to-business direction. Well, sustainability is not a new concept. The Indians, the Iroquois nation, which was composed of 6 tribes, in 1500 had a constitution, and the constitution said in every deliberation you must consider the impact for this on the 7th generation. That meant at that time about 100 years. Today it's about 150 years. But that's very nice to see that, you know, these people, the Indians, you know, that we don't consider illuminated by our days, that they had this foresight. Well, how it should be. You see, you know, natural resources should be found. Water, you know, he's talking about, you know, minerals, you know, agricultural products that, you know, they're transformed, used in industry by an optimal location. You know, people won't, you know, use them in a bad way. It doesn't make sense, economic sense, and people will buy it and be happy. Well, use it, feel good. You know? And then after the life cycle, they will recycle it, and then it becomes natural products again. Well, and it's all based on, it's all permeated by technology. All these things, technology has a huge impact on any phase of this. Well, how it is. This is the way it is. You see, low quality jobs, you know, a lot of pollution, a lot of scarce material, you know. Big problem is that many countries lack the education, political will, as you know, Abdul was saying, infrastructure and resources for the adequate management of the old equipment. And we is very diverse. You know, we usually think about we as being ICT only, you know, equipment for communications and information. But it's, you know, all the appliances, entertainment, transport, tools, infrastructure. You know, infrastructure meaning the, you know, the TVs and radio base stations, industry, and has machinery. Commerce and banking. The scenario is electronic revolutionized lifestyle, communications, entertainment, industry, education, healthcare, and are becoming wearables. And not only wearables, you have heard the electronic of the Internet of Things, which means that you know, the TV, your refrigerator, your bathtub will all be connected to your cell phone. And you will say, well, I'm going to arrive home and I want the hot water, I want the TV to work, and things like that, you know. Products are coming more efficient, more powerful, less expensive, more desirable. Who wants to have a 10 years old cellular phone? You know? But it was a shorter life. You know, every 6 months, I just bought a telephone, a brand new, fantastic Samsung, 6 months ago. It's outdated already. ICT is an indicator of economic and social development, but there is a digital divide between the developed countries and the underdeveloped countries. We, Brazil, Egypt, and many other countries, we have access, but the developed countries have access much faster than we do, and at a much better price also, much more affordable for them. Well, what to do with the we? You can reuse it. Yeah, you can reuse it. And the origin of this we is normally local, like your refrigerator that gets a little bit old. You put a new one in home, and you and you give the old one, or you sell the old one, or imported. Africa receives a lot of second-hand equipment from Europe, and that can be good and that can be bad. But it's most of the time you'll see that I have statistics on Nigeria, and most of the time it's reusable. And the end of life. The end of life means recycling, and you don't want to receive junk, unusable junk from the Europe or United States. You want to, just keep it local. You have to take care of your old equipment. The advantages in Second Life is that you can bridge the digital divide. It's more easier. You can get used equipment that are perfectly good for most of the people, and not the last the last model that came out in developed countries, but something that is still very useful and has a long time of use. And that will help, of course, bridge the digital divide. And then you can create jobs and businesses for refurbishing all kinds of we. The advantage of recycling is that you can market the metals and other materials. You can clean the environment. You can create jobs of dismantling and sorting. And you can create a recycling industry. Urban mining means what everybody has in its drawers, old cell phones, the liquefier that is not working. You bought a new one, but you don't know what to do with the old one. You have chargers, you have iTabs. Everybody has this kind of things in home, and that's in a ton of this we that's in our houses. There's more ore than any mineral. There's iron 35%, copper 17%, lead to 3% or 2%, aluminum at 7%, zinc 4 to 5, and there's gold, silver, platinum, fiber and plastics that can have a second life, paperboard and cardboard that also can have a second life, and the non-recyclables that still can be used for construction. They have an example of Nigeria. Nigeria receives a lot of products of we from Europe, and the majority of the refurbished are the refurbishing products they receive is from Europe, and 70% of it can be used just by testing. They test it, little things here and there, and you can use it. The 70% of what is not can be fixed, and 9% of it goes to recycling. Okay. The result of this, they built an industry around it. They have 8,000 ICTs refurbishing enterprises operating just in Lagos. That's work for 21,600 people. They have the refurbishing in Lagos generates $50 million per year, which is a little bit of small percentage, 1% of Nigeria's GDP, but it's still something. Egypt, and the second thing is this $50 million probably is understated, because there is not really, when you get these kind of shops, when they get the material, they refurbish it and they sell it, and I'm sure they don't take a fiscal bill or something like that in foreign to the government to pay taxes. So that's probably understated. Egypt, you generate about 4 kilos per year of waste, electronic and equipment. And that's added by 82 million people. That adds to 314,000 tons per year, which is quite a lot. You have some examples here of use of mostly Mobinu that has a nice, I don't think you can say a school of e-recycling. Mobinu has handset batteries, radio bases, and other things that they refurbish. Sedari, Vodafone, Nokia, Oracle, Risala, etc., that they all work in this area of recycling and refurbishing. And there's a warehouse here in Alexandria port of apprehended WE that's completely full of equipment that could be used, that can be, I don't know how it works here, but normally it could be sold to refurbishing outfits. Well, there's something that you're missing. Everybody in the Egyptian industry works with ICTs. ICTs are very attractive. They have a ready market, cell phones, computers, laptops, and they have a ready market. But they're not the only thing in the we, European Union data shows that of the percentage of ICTs account only for 14%. TVs 11%, and large and small household items 65%. Okay, your refrigerator, your washing machine, your radio, and things like that. Another 10%. 75% of the we is polluting and wasting materials and neglected as a business opportunity. This represents 180,000 tons of metals. That has a large value. What is required? You have to develop a legal framework. The other day, yesterday, the Laila, the Minister of Environment, was saying about the legal framework, and it has to be something that's enforceable and punishable, right? You cannot have a lax law, and I can tell you with knowledge, because we've been in Brazil discussing the law for 20 years. And it's in place, but it's so difficult to work with it. That's it's a nightmare. You have to educate the consumer not to throw out things in the street. You have to develop collection points and hubs and pickup operation. This is very important because nobody is going to pick up their refrigerator, put them in the back, and take it to anywhere. So you have to establish some way a system that goes to their houses, picks it up. There's a logistic from the hub, the collection hub, to the processing plant. You have to establish, organize, and refurbishing and disassembly operation at the processing plant. And you have to organize the commercial activity. You have to know where to sell these things you're going to process. And how to finance it. You can finance it through a consumer tax at purchase. So you go to the shop, and the shop will say, well, this costs $100 plus 100 pounds plus 10% for the future collection and the processing of it. Or you can, that can be included in the price. So instead of paying 100 pounds, you would pay 110 pounds because the commerce will have to turn that into people that the company or the business that will reprocess it. Or you can have a tax at producer level that they will pay. Maintain the system working. In Brazil, it's not sure where we're going to be taxed yet. The government, the law says that the producer is the responsible for doing it. Well, what are you going to do about it? Thank you very much. That's it.
Questions? Yes.
I'm sorry.
Well, do we have any question first for the current speaker?
Yeah, first the current speaker.
Go ahead.
Okay, go?
Yeah.
Okay. Dr. Abdurrabbu, I want to know the time elapsed since you start. The time elapsed since you start the project till you measure the effect, the changes you measured of the rising of the sea or all the effects.
Well, actually, we are not
How
measuring.
many years?
Yeah, we're not measuring the change in sea level, the mean sea level. But CORI, it's the Coastal Research Institute, has a number of monitoring stations along the Mediterranean coast and have been collecting data about that since the 60s. And they have developed their own scenario about if this trend will continue, what's going to happen by 2025, 2050, up to 2100. And that's one of the scenarios that we're using.
So there's projection for the
Yeah,
data to know
we're talking, if we,
coming.
yeah, let me clarify this. If we're talking about 50 or 100 years' time, you cannot do prediction. You cannot predict because it's a very long time that we're talking about. So what we have to do is to do projections under different scenarios, either with the IPCC or other ones like business as usual, demographic trends in Egypt, and so on.
But you know there was so many talking about this, and they say the sea will rise 1 meter and 50 centimeter or 50
There are people talking
centimeter
about
or
40, 50 centimeters, people talking about 1 meter, people talking about 2 meters.
Yeah, but they are talking. But
They are talking.
did
That's
we
the
measure
problem.
Did we measure any change?
Yeah, but yeah, there are changes.
How many centimeters? It's difficult.
I cannot give you the exact number right now, but it's measured by, as I said, by the Coastal Research Institute, and we're talking about by 2100. I think they're talking about like 45 centimeters around that.
They said after 50 years it will be 50 centimeters.
Yeah, but that depends on the previous measurements.
Okay.
Okay.
Thank you very much.
Thank you.
Well, I have a question for you. This recycling business, the recycling process itself, is it environmentally friendly, or does it involve a lot of nasty chemicals?
No, it's mostly physical. No, it's mostly physical. You have where you have the nasty chemicals is okay. Let's separate it. Everywhere you can separate, break down the equipment into its parts. There is some parts that are. Every country has it. You have a steel industry here, and you have aluminum industry here. You have, but you don't have a components industry, right? So what happens, and what happens is that you it stays in the country, in Brazil, and then stay here in the part that is recyclable at the local. So steel, aluminum, glass, and things like that. And you will export to about 5 places in the world that do the separation of the gold, silver, platinum, rare earths and things like that. And that's only 5 or 6 plants in the world. You have one in Belgium, you have two in the United States, and you have one in Singapore, and probably have something in Japan, and you know, it's a very few places. And so, and these places where they do this, they use nasty chemicals. But these nasty, it's you know, huge plants that are very, very, very well equipped, and they run very well. So there's there's more benefits to the environment than leaving it there. And there's one problem with that, is that, you know, a lot of people think, oh, there's gold here, and they heat it.
Yeah,
And they heat it and they make a mess, because then they use, or they solve it, and then we saw just the pictures there. That's it, you know. And you've seen people. There's one place in China, one city there, that's, you know, you cannot get in because you cannot breathe the air, you know. Okay.
Well, any other questions?
If you visit India, you will see how they extract all the metal from electronic and electric wastes from all appliances. They do a very good job. They get all kinds of metals, which you said, iron, copper, everything. They extract it from all these appliances.
Not really. I have awful information from that.
This
is in India. In India, it's done in a way that really is very bad for everybody, for the health and for the environment.
Yeah, maybe when they took us to the visit, they were cleaning.
Well, could be that there's a plant there. Could be that there's a plant there. I don't know of it.
Yeah.
Okay.
Okay, thank you.
Okay. Well, thank you very much. Okay, so moving on, it's my great pleasure to introduce Professor Salah Hassouna. He is a professor of industrial and environmental microbiology at the Environmental Studies Department in Alexandria University here in Egypt. His main research interests are in fermentation technology, biofuel production, and waste management. He supervised, more than 60 graduate students on these subjects, and obviously he authored so many papers on this subject, and he teaches at the Departments of Environmental Studies and Biotechnology at IGSR. He has several awards from Alexandria University. He had multiple visits to Cornell University, and he's active in so many projects that I can't really read all of it. So the floor is yours.
Good evening, everybody. I would like first to thank you, the organizing committee of BVA, for inviting me to be here and for the nice introduction of the chairman. In fact, I am a biovisionist since the very early start in the year 2002. And today, actually, I'm honored to be here to talk to you about one of the subjects we are working with recently. And it's about carbon dioxide sequestration by algae. The thing is, you've heard about the problem of global warming. You've heard about the rising concentration of carbon dioxide in the atmosphere. In fact, in the last maybe 2 decades, it's very alarming. I mean, the increase in the carbon dioxide concentration. Carbon dioxide specifically is a gas that loves heat. In other words, any infrared rays, for instance, any heat, carbon dioxide is a very, very good absorber for heat. So in other words, one of the major problems of the global warming is the formation of carbon dioxide. Because of the carbon dioxide elevation in the atmosphere, we are expecting, as Dr. Abdul said, sea level rise. I'm not going to talk about how many centimeters or so. However, it's really a problem. So according to the Kyoto Protocol, according to several international organizations, it became an important issue to sequester carbon dioxide or to capture carbon dioxide and get rid of it one way or the other. Actually, carbon dioxide sequestration is a set of technologies that can greatly reduce carbon dioxide from coal and gas-fired industries in a 3-step process that includes, first, capture the carbon dioxide from the industrial processes, then transport the captured and compressed carbon dioxide, then store it or utilize it by geological, physical, or biological means. The technologies for carbon dioxide capture include geological sequestration, chemical adsorption, solid adsorbent, membrane technology, cryogenic fractionation, use of microalgae, and that will be the focus point we're talking about. Geological sequestration is injection of carbon dioxide to oil wells or to underground geological formation. This has to be, after the injection, has to be layered with a non-porous layer of rock to prevent the carbon dioxide release again to the environment. Remember one thing, that each of these technologies has its advantages and disadvantages. So we are going to mention why this technology is used and what are the drawbacks of this. So the drawback of this technology is the continuous monitoring of carbon dioxide is really expensive. Chemical adsorption is done by monoethanolamine and has been used successfully to separate carbon dioxide from the industrial flue gases. However, its regeneration needs heating at more than 100 degrees Celsius, requiring actually a lot of energy. Remember one thing, that when we are talking about the regeneration, it's not just the heat produced during the process. However, it's also the electricity or the fuel used during the process. For the regeneration of the monoethanolamine, 1/3 actually of the absorbing carbon dioxide capacity is being already emitted. Another thing is the third absorption by activated carbon or the zeolite. They are used as a low energy input and cost. One of the drawbacks is the moisture in the flue gases that can lower the efficiency. And another actually obstacle is the presence of SOx and NOx that would poison the absorbents. And usually in the flue gases, you might find SOx and NOx in many industries. Membrane technology is another option. Based on the permeability and selectivity of the polymeric membranes, they can actually have much lower energy consumption. However, cooling of the flue gases is essential for membrane separation of the flue gases. We're going to know that the temperature of the flue gases might be over 400, and in such case, it might ruin the membrane. The moisture also is another barrier, along with the membrane fouling and high cost of large surface area required for the industrial gases. Cryogenic fractionation has been used, for many years to separate gases through cooling unit. They enter the liquid state. Due to the different heats of the vaporization, a liquid gas mixture can then be separated. In other words, this technology has been used for many years to separate the gases. It's really high efficient technology widely applied in air separation based on cooling and condensation of multi-gaseous components. However, its drawback is the high energy requirements along with the effect of moisture content. So, as you can tell from all the technologies we talked about, no one of them is really, a robust technology that can be used. Algae came as an alternative, and it's a biological system, it's cheap, and has many advantages. In fact, algae can be one of the things that could help in sustaining the carbon cycle. In other words, of course, algae can capture the carbon dioxide, and then algae can be used for production of bioethanol or biodiesel. And by burning bioethanol and biodiesel, we get carbon dioxide, which is being taken up again by the algae and so on. So it's actually can be a closed cycle and can keep the carbon dioxide balance well in the environment. Algal capture of carbon dioxide depends on the requirements. For instance, algal cells contain about 50% carbon, in which 1.8 kilograms of carbon dioxide are fixed by producing 1 kilogram of biomass. The microalgae, they are very potent in using carbon dioxide for many reasons. One of them, they divide in hours, mostly in 1 or 2 days. And the other thing is carbon is converted to carbohydrates and lipids. Carbohydrates can be used for bioethanol production. The lipids can be used for biodiesel. That's just one example. The high growth rate, I mean, at higher carbon dioxide concentrations, the carbon dioxide concentration in the air, for instance, is about 0.033. However, I mean, in the flue gases or industries, it can reach up to 20%. So when the algal species can take up to 15 or 20% of the carbon dioxide, this is really one of the advantages. Another advantage of using the algae is a high photosynthetic rate that than terrestrial plants, reaching maybe 50 times greater in converting solar energy to chemical energy. As I said before, it's maybe 100 times faster growth than plants. Again, lipid from algae can be used as a biofuel, and the algal mass could be used for various applications, including for animal feed, for fish farms, for poultry, as a soil mulch. There are many, many uses for the algal biomass itself. The disadvantage of using algae comes from the fact that they are really tiny organisms and they are unicellular, and that's what gives them the chance to multiply rapidly. However, harvesting and drying algae takes a considerable quantity of energy. That's its production emit large amount of carbon dioxide. We will see how we can deal with that. Carbon dioxide injection into the algal cultures is really a problem because of the solubility of the carbon dioxide. As you can see from the graph, that solubility of the carbon dioxide decreases with the temperature. And actually, at 25 degrees, the solubility in water is about 1.45 grams per liter, which is very, very low. This is during the, I mean, with the normal pressure, 100 kilopascal is actually atmospheric pressure. Again, there's a very good way to use the algae in an efficient way. Many of the microorganisms, if they are under stress, they produce products that you want to use in a different ways. A two-stage cultivation process, meaning that you can grow the algae and then subject them to starvation, nutrient starvation or carbon dioxide or any nutrients. This actually increases the lipid content by almost threefold. Again, increasing the carbon dioxide will increase the polyunsaturated fatty acids. The polyunsaturated fatty acids is a very, very important raw material for producing biodiesel. When we talk about Synedesmus species, for instance, 76% of the lipids will be linolenic and linolenic, and we are talking about the 16 and the 18 and the 20 carbon fatty acids. We are talking about the unsaturated, the 18.1, the 18.2, the 18.3. So basically, it's actually an added advantage by increasing the carbon dioxide because they will form the type of lipids that are suitable for biodiesel production. This table actually is a very important one because it gives an idea about the carbon dioxide tolerance, and then how much could be fixed, what's the biomass product, and the lipid content. From this table, you can tell that we can get lipid content up to 45%. However, it's the tolerance of carbon dioxide is only 2%. So if in industry that carbon dioxide is not as much as the others, then this could be used. However, if the carbon dioxide concentration is around 20%, then the Synedesmus will be the choice, despite the fact that the lipid content will be less. The systems of growing algae is really, I mean, there are many, many systems, including the raceway ponds. This is a Formula One kind of structure for growing algae, or a photobioreactor. The problems of the industrial flue gases comes from chlorella, for instance, can survive in the presence of SOx and NOx up to 240 ppm and 80 ppm respectively, while other species could be totally inhibited. In other words, if the flue gases has some contaminants, then the choice of the strain is a must. The growth of Syndesmus lanialiella is not affected if NOx and SOx are less than 150 ppm. The dissolved nitrogen oxide could be oxidized in the culture media to nitrate before being uptaken by the algae as nutrients. When we inject the flue gases into the algal pond, sulfur dioxide could form bisulfides, sulfites, and sulfates, causing various reactions, leading to cell membrane malfunction and loss of chlorophyll. In other words, I mean, this is really one of the drawbacks of the process. However, SOx in the flue gases would cause a drop in the pH, and the flue gases of over 60 ppm are not suitable for the process. So the solution is to remove those gases, which could be done by limestone gypsum method. Another obstacle about injecting the carbon dioxide into, from the flue gases into the algal pond is a temperature. If the temperature is high, then cooling has to be done. Cooling means more energy input in the system. The microbubble technology for enhancing the carbon dioxide solubility is another alternative. The carbon dioxide mass transfer is very slow. Continuous bubbling is thus required. However, microbubbles of tiny microbubbles have high surface to volume area, slower rising velocity, and faster dissolution rate of the gas to liquid, indicating longer residence time. We can tell from this figure that if you have a macrobubbles, then actually they will rise up rapidly and then they burst at the surface. However, if you have microbubbles, then they will decrease in size and burst underwater, meaning that the solubility of the carbon dioxide in such case will be much better than if you have macrobubbles. So basically, the microbubbles also have additional advantages. They strip the oxygen produced, of course, by the algae effectively into the atmosphere, which prevents oversaturation of oxygen that has toxic effect. We know, of course, I mean, if you have extra oxygen, then free radicals and oxidation and so on. The other thing is bubbles do not collapse underwater and thus do not create shear stress that can damage the algal cells. Making of microbubbles is not easy. On the other hand, it can be done by acoustic cavitation, by hydrodynamic cavitation, by pressurized gas-liquid circulation, by fluid oscillation, by microporous diffuser. And the very last one is the easiest. A hollow fiber membrane system has been suggested for making the microbubbles. The fine bubbles are generated through a membrane, and actually the porosity will allow the production of very fine bubbles. One of the drawbacks of the membrane bioreactors is the cloudy dispersion of the fine bubbles with reduced light penetration. And of course, light is important for the algal growth. A two-unit system had been suggested for that. It could use actually, I mean, part of it is only for the gas delivery and the other one for the light delivery. The drawback of this system that you need pumping between the two units. So that's also an extra cost, not just extra cost, but extra energy. And remember one thing, that when we talk about energy, we talk about carbon dioxide emissions. This is just an example of the huge bioreactors, photobioreactors that can be used. The photobioreactors can be indoors or outdoors, and the major difference is light. In other words, if they are outdoors, in such case, they will be subjected to day and night circulation. However, if they are indoors, you can have continuous light all the time, and then you don't have carbon dioxide emitted during the dark periods. Another alternative is using the carbonate, or the soluble carbonate. Carbon dioxide has very low solubility in water, as we said. Hence, intensive energy is needed for continuous pumping of gases. Carbon dioxide concentration is inconsistent in the flue gases unless the source is very close to the algal culture. In other words, if you have a power plant and you need to do an algal culture, it has to be really close to the power plant. And one of the obstacles in that usually around power plants, there's no land. So this has to be taken into consideration. Another thing is, if you want to transport the carbon dioxide, then the high cost of compression and transportation will actually represent nearly 30% of the cost of the recovery process. The bicarbonate alternative, when carbon dioxide dissolves in water, 3 types of inorganic species are formed depending on pH. Below pH 4.5, free carbon dioxide or carbonic acid is formed. Between pH 4.5 and 8.5, bicarbonate is a dominant species. Above pH 8.5, the carbonate is a dominant species. The bicarbonate actually does not diffuse across the cell membrane. In other words, it's not taken by the algae. But with carbonic anhydrase, the enzyme, it's converted into carbon dioxide and then transported into the cell. This is really a crucial issue for the people working in the field of biotechnology, because they can play with the genes responsible for the carbonic anhydrase and increase its capacity. And, all the genetic engineering approach can be done easily in this part. And the uptake of the carbon dioxide can be enhanced by genetic engineering. The advantage of using the bicarbonate, actually adding the bicarbonate to chlorella yielded almost 40% increase in lipid content. The bicarbonate has higher solubility and retention time compared to carbon dioxide. The carbon source could be stored temporarily during dark periods. That's another issue, that during the dark period, actually, carbon dioxide is being released by the algae. However, if you are using the bicarbonate system, then there is a storage pathway for the carbon dioxide. Again, the carbon dioxide from the flue gases could be captured by something like the sodium carbonate. Sodium carbonate actually is an inexpensive absorbent, and then it could be released by heating at 120 degrees. The system does not require pumping, so it's not added cost. Some algal species can utilize the carbonate directly as carbon source, reducing energy consumption, but not all algal species can use the bicarbonate directly. This is, again, another aspect of biotechnology, is how you can make some of the strains that are, for instance, efficient in lipid production and so on, how they can utilize the bicarbonate as a source of carbon. The recommended system in general for doing the algal cultures is to have a raceway algal ponds. Carbon dioxide can be injected into these ponds. Then a coagulation step, followed by lipid extraction by solvents. There are many, many ways of extracting the oil from the algal cells. However, as we can see, in the next slide, you will see that the lipid extraction by solvents is the least expensive, as much as also the carbon dioxide release in the environment. This will be followed by a trans-esterification process and then producing the biodiesel plus glycerol. We have to look at life cycle analysis. Life cycle analysis is very important in this issue, because we have to look at 2 things. First of all, carbon dioxide balance and the energy utilized. When I said that, I mean that probably you could suggest a circulation system. And circulation system needs pumping. Pumping means electricity, means energy, means carbon dioxide emission to the atmosphere. So everything is related to its origin. It's the life cycle analysis is, as we said, is from the cradle to grave. From the very beginning of producing the energy to the final product. So looking at that, you will see that the photobioreactor, the flat plate, the raceway pond, actually they have the least carbon dioxide emission compared to the tubular. Now, if you look at the harvesting step, the coagulation and fluctuation is the least producer for carbon dioxide. Centrifugation and filtration would produce more carbon dioxide. The trans-esterification and lipid extraction, they don't actually responsible for any of the carbon dioxide emission. So at the end, I would say that full life cycle analysis is still needed until now. It's been proven that raceway ponds uses less energy than photobioreactors, meaning less carbon dioxide emission. Open systems would cause more water loss by evaporation, along with carbon dioxide escape to the environment. Coagulation fluctuation system emits 28 to 40 times less carbon dioxide than centrifugation and filtration, but it might affect the final product because if the final product, for instance, if the algal mass would be used for animal nutrition or for extracting vitamins or anything, then the fluctuation coagulation, you have to be very careful in choosing the material. Again, the solvents for the oil extraction should be recycled for sustainability, otherwise you will be losing valuable chemicals, and those chemicals, the production needs energy, which would emit carbon dioxide. The last thing is that solar drying of algal mass saves energy, and in hot countries it's feasible. However, the problem would be in cold weather. Well, I think at the end I would say that new life sciences could save the environment in the next decade. Thank you.
Questions?
Thank you for a wonderful presentation. I would like to ask what are the opportunities here in Egypt to construct outdoor and indoor photobio reactors?
As a matter of fact, we have already started this process with one of the petroleum refining plants here in Alexandria. And we are sequestering the carbon dioxide coming from one of the stacks into algal pond. And some of the data you've seen already is part of that work. And we are also testing at the moment the bicarbonate system as well. So it's feasible really. And the other thing that's related to this, that biodiesel became an important issue in many countries. And even here in Egypt, many people, the holding company of the petrochemical actually is investing money in making biodiesel. And as far as I know, we have exported already some of the biodiesel that's coming from Jatrova. Algal ponds is definitely one of the solutions for many things. As a matter of fact, one thing I haven't mentioned, the carbon credits. And maybe we can get extra benefit from the carbon credits as well using a system like that. I hope I answered your question.
Only here in Alexandria Governorate?
Oh no! It could be in everywhere in Egypt. As a matter of fact, maybe some of the algae will be very happy in Aswan or Luxor. Yeah, I mean, yeah, the high temperature is really an advantage.
Yes, in Upper Egypt.
Yeah.
Yes, thank you.
Okay, thank you.
May I?
Yes.
Would you please?
Have you tried feeding the algae with glycerin?
We haven't actually tried feeding algae with glycerin. No, we haven't, because actually the main carbon source we would like the algae to use is carbon dioxide. So we haven't really tried glycerol or glycerin as a feed. We are mainly interested in the sequestration of carbon dioxide.
Yeah, and the nice thing about doing it here in Egypt is that you have all the sunny areas around the Nile, right? You know, it's so it would be very, very useful to.
Well, as a matter of fact, I think, I mean, glycerol is a very good product, and its value is high, and it's used in many industries.
Yeah, but it is, but it has, it's becoming a problem because you have a lot of production of biodiesel in Brazil. At least it has become a problem of what to do with it.
I think it can be used for shampoos and
yeah. But you can only use that much of it in shampoos. Yeah.
Yes. All right.
Yeah, go ahead.
Would you please, may I ask you, does the type of starvation affect the quality of biodiesel produced?
The thing about starvation, actually, it's really something about microorganisms in general. If you put the microorganisms under stress, they will produce something you don't expect. Let me just give you one example. that if you, the chlorella, for instance, if you deplete the nitrogen, then the lipid content would be doubled. Same thing with all the secondary metabolites. Most of the secondary metabolites, like vitamins, like antibiotics, and so on, if you put the microorganisms under stress, especially nutrient deficiency, then they will produce something really entirely different. Remember one thing, that if you start with nutrient depletion, then the growth rate will be very limited. However, you have to start with nutrient-rich media and then do the starvation cycle.
The last question, why this type of biodiesel is failed in Egypt? Many persons try to make this biodiesel production in large scale and they failed. Why?
They failed?
Failed, yes. Why?
They don't know how.
No.
They don't know how. We have done it many, many times. I mean, we do have...
Large scale?
We do have here one of the experts, actually...
As a pilot scale or large scale?
Small scale and large scale. I mean, it has been exported already. One of the companies here in Alexandria, they have exported, I don't know the quantity exactly, but I think it's over 20 tons of biodiesel in the last couple of months, coming from the Jatrova oil.
From Jatrova, not from algae.
No, from algae, it's been until now experimental, and there is a place in near Suez.
Yes, and they failed.
And actually, there is a group in Mansoura University, and they are doing the RD work for one of the American companies, and they have a place near Suez. And do you know that? I mean,
yes, I know them, and they failed.
They failed?
They failed, yes.
Well, they don't tell that.
They're still trying.
They haven't told us that they failed, actually. Well, let me ask you, I mean, what type of failure is it? They haven't produced the biodiesel, or the cost is... the cost. Yeah, the cost is still a problem. I know. I mean, it could be a problem. But I mean, they have not failed technically.
Production of a product high costly is a failing.
Now, when you talk about fuels in general, remember one thing, which is happening in Egypt: subsidies. Subsidies is really killing many of the technologies about biofuels. When you compare prices of production of any for instance, biodiesel, do not compare it to the current price of diesel in the pump station. Compare it to the original price. And definitely, the production of biodiesel will be much cheaper if you omit the subsidies.
Thank you.
You're welcome.
Well, thank you very much. And that concludes our session. Thank you.